This video is meant as kind of just a general introduction to the topics that we're going to look at this semester in Calculus 3. Essentially, Calculus 3 is the multivariable calculus class and basically does everything that you did in Calculus 1 essentially with a little bit of Calculus 2, but extends the number of variables to more than one. So you probably remember from, say, Calculus 1 that you looked at functions f of x, and you would have plotted them and you would have gotten some sort of graph in the xy plane or something. Well, in this Calculus 3 class, we're going to look at functions of, say, in this case, two variables, f of x, y. And if you were to plot them, you're going to look and you would see that you get these three-dimensional objects. So Calculus 3 is a class where we need to try to figure out how to deal with three-dimensional objects. Like in Calculus 1, you know that I'm just adjusting this plot a little bit. This software is called Mathematica. We'll learn how to use it some this semester. But notice that what I'm doing is I'm just plotting this function for different values of x and y. So my x values go from negative 0.5 to 0.5. And my y values go from negative 0.2 to 0.2. And if I plot this function, the same function, over those values of x and y, I get something that's kind of flat in nature. Okay? But if I were to zoom out on it, this is where we start to see that the surface has a little bit of bendy shape, right? So the idea that's going on there is that if you zoom in on a particular region, right here maybe at this point, just like in Calculus 1, that if you zoom in on a function, you will get something that looks flat, called the tangent line. Well, in Calculus 3, we have this thing called the tangent plane. So that's just kind of an introduction to this particular kind of function, f of x, y, right? A function of two variables. One of the difficulties with this Calculus 3 class is that you have more than lots of different kind of functions that are out there. So for example, let's take a look at this. There are functions of, let me just run this function. Okay, functions of three variables. Functions of three variables. And in this case, I'm looking at the function of three variables equal to a constant. Well, you can zoom out on this, like we did with the other one, and now we're getting something that looks quite a bit different. We're getting something that looks like it's a 3D object, but it looks vastly different than the function we had before. First of all, yeah, well, we'll talk more about these, but you can adjust, and now you have some sort of, I don't know, piping system, so where water can flow through this way and they can also go out the other way. So here's an interesting looking function or surface, and it is a function of three variables. So we'll learn how to deal with these kind of objects. So the first part of the semester is just kind of getting used to working with functions of 1, 2, and 3 variables, right? And then the functions of one variable, kind of getting to objects that look quite a bit simpler but are no less important. Right, let's take a look here. Here is a function of, here is a function of one variable, but it is also it's in 3D, but this is what's called a curve. So these curves are going to be very important to us because they will let us talk about doing derivatives. So then after we introduce the objects, we will move on to objects, meaning that the curves and surfaces in 3D. We'll then move on to how do we actually compute derivatives, and we will see that the idea of derivative is quite a bit different, not quite a bit different, but enough different that we need to really spend some time on it. So if you want to take the derivative of a function of two variables, you're going to need to be able to draw curves on that surface and then compute the rate of change of the function in a given direction. And that's what's called a directional derivative. And that will show us how the function, if you're on this hill, how the function will change, or how steeply it will change if you walk in this direction. If you walk in the other direction, the function may change less steeply or more steeply. So here's a direction right here. If you walk in that direction, that's the steepest direction because it looks like it's leading you right to the top of the hill. So, we'll spend some time introducing functions, curves, and surfaces, and then introduce derivatives. So that's essentially what you would do in Calculus 1. Talk about functions and then talk about derivatives. The next part of the class will then be doing taking these curves and surfaces and then introducing different kinds of functions called contour plots. And the whole idea here is that we are trying to do the max-min problem to figure out where does a function have a maximum or a minimum. And I think we can see that according to this picture, the minimum of this function is right there, right there in the middle. And if you stare carefully at this plot, you can see that this plot is the same as this plot, though just oriented differently. So that actually will take a bit of time for us to discuss the nature of the contour plot of a function of two variables. But the idea there will be to use this information to help us find maxes and mins. So that sounds very similar to Calculus 1. You introduce functions, do derivatives, and then you do derivatives so that you can do the max-min problem and an optimization problem. Okay. And then there are many other things that we could do, that we will do in this class. And then the next part, maybe I don't want to discuss, but we'll talk about moving from the derivative section to the integral section. So just to let you know, this is what I'm showing you is just some demos that I've created. The software that I've used to create these videos is in what's called Mathematica. And this software is freely downloadable for you from the university. If you would like to download this software and use it on your own personal computer, I recommend downloading it through an Ethernet wire. Try not to download it over the Wi-Fi. It's a relatively big file and it will take up some space. So what we're seeing right here from our website, course links 2130, here you have a bunch of Mathematica demos, and the download instructions are here through the university. I've got a link there on our website under the Mathematica demos. The file that I was showing you with all the different demos is right here. And here throughout the semester, some additional Mathematica files that I will put up. And these are also in the Mathematica examples shared folder in the Google Drive. So that's just kind of an overview of what kind of topics we'll be discussing this semester in Calculus 3, and it's all about dealing with three-dimensional and two-dimensional objects and doing calculus with those. So that's probably enough for now. Hopefully that gives you an idea of the kind of topics we're going to be looking at and gets you interested in the subject. So that'll be all, and for more, come to class and we'll go from there. Later.